We were using an abstraction, Verilog abstraction language, so we don't have to make gates and all of that. But there is one level, again, above that. And that's what the people of the MyGen and LiteX project have been working on, is to be able to work with all this stuff with Python. So you will describe your design and you reuse highly complex pieces of design just by plugging it Python modules and importing Python modules. So initially it was made to make a system on chip where you will just arrive, put your thing and say, I want a RISC-V CPU with HDMI, Ethernet, and USB and whatever else you want. And then you can decide, oh, I just want to change the CPU, and just flip a command and change the kind of CPU you have on your board. Nothing else changes, everything works as the same, and you just compile for a different kind of CPU. And then you can decide you have a bigger board, and then you can say, well, I want to boot Linux on it. And you can boot Linux on the thing and have SD-RAM connected to it, have SATA.
Will Linux run on this?
No, yes, but you need an SD card to make it work.
You need what?
You need an SD card, PMod, to make it boot because you don't have enough RAM. If you go with... If you go with these, which are the... it's a hackerspace in Zagreb where they made their own FPGA boards. That's called the ULX3S. I will have a new one, which is the ULX4S, 4L something. And that's the same kind of FPGA, except that it comes with an ESP32, a bunch of buttons, I2S, USB on the board, and all of that.
What's the name of the company?
It's not a company, it's a hackerspace.
Oh, okay.
And yeah, so it's Radiona hackerspace. And that with this one, you have serializer and deserializer, and you have a lot of RAM, and you can boot Linux on them without any issue. So that's the idea, to have your board with all these things populated. You have a module for, as I said, for the SD-RAM, the HDMI, you have SATA. A lot of these things you will not be able to do on that board because it does not have a serializer, deserializer. It's just the model above that one that has that.
It doesn't have what part?
SERDES.
Oh,
So,
sure is. Okay.
A what?
so it's a serializer, deserializer.
Serializer.
Yes, SERDES is serializer, deserializer. And that's used to when you have really high-speed serial signals. So you have a hardware part in your FPGA that decodes that and can handle that. So you don't need...
You're not writing a UART for yourself.
You still are, but you can use ultra-fast clocks to get that information out as fast as possible. So, and you don't have all kind of clock issues you will have on these things.
Open cores?
I will talk about that.
Yeah, okay.
Yeah. Maybe it's time to talk about that, by the way. Okay.
Round zero.
I thought they went away. No.
No,
Okay, so on the website you will see there is a presentation. There are a bunch of videos on semiconductors on YouTube where someone explains how semiconductors works and where they come from and what are the difficulties with manufacturing these days with extreme UV and all of that they have. So it's pretty cool. And when I was talking about the 0 to ASIC course and eFabless, you will see, follow these links and you have a lot of explanation on how to make your own ASIC or see what people are doing these days where you can get your own chip made. And the last one is the open course. So that's one of the, if not the major module reuse website. So you just go on there and say, I want a unit that does multiplication. And you just take that and use it.
What's the smallest amount of money that you can spend and touch any of this?
What, that? The ASIC? 0.
it's a repository of code.
No, he was talking about the ASIC thing.
Oh.
So it starts at 0. If you don't want to deal with open source and all of that, I think they start as 10K.
I actually meant the chip. Yeah,
Yeah, 0.
that's what we're saying.
If it's open source and you
No, I mean, purchase. I mean, I'm talking about purchasing a physical thing in order to put this stuff into it. The receptacle which holds this.
for what? For
Physical thing.
for the FPGA one?
Yes.
So that you want the price of that? The cheapest one you can get is $13 probably these days. Unless you want to go with a Chinese FPGA, which is much cheaper but less documented. But
Do you want it soldered or just get a board?
the Colorlite generation before, that has only outputs, so yeah. And this is $50. Without the Ethernet, it's $50 ish. Okay, so yeah,
Oh wait, the $18 board.
yeah, but this one has just outputs, and you have to do a lot of manual work to get the
You
inputs.
want cheap.
Yeah, that's cheap.
And there are
No, I
boards.
said, what's the least money that you can pay for a physical receptacle that holds the code we're talking
Yeah,
about?
$18.
And $18.
Well, 0 today, but yeah, if you, yeah,
Thanks to our benefactor again.
but if you, yeah, if you just want outputs or you are ready to unsolder components and solder things yourself, $13. If you don't want to do anything and you want that, 50.
And the other thing too is you can get dev boards that have things like 7-segment displays on them that have dip switches,
Yeah,
push
a
buttons,
company called Digital.
even
they
an
sell.
accelerometer or something like that.
yeah,
You can
Digilant has-
You can get boards that already are populated with a bunch of pieces of stuff.
And
around.
yeah, Digilant, every year Digilant, they have big sales where you're going to have boards for close to nothing. Just have to be careful if you want to use the open source stuff. Not all the FPGA will be handled.
Yeah.
So just be careful what you choose. In most cases, the software is free when you use really cheap FPGAs. But as soon as you want to use fancy FPGAs, you have to pay the big bucks, like really big bucks. Okay, so just for the sake of it, of what we are doing here, that's what a silicon crystal looks like in reality. And that's the one that's going to get sliced and is going to make your silicon wafers. That's a small one. They are much bigger now. And that's the kind of crazy stuff people are doing now with silicon, where you have tens of layers of different materials that are on top of each other. And then now you have dies over dies. So you can have, on your same chip, you will have a chip that has 7 nanometers, which interface with one at 13 and one at 50. And so this is crazy stuff.
They
And
said for a long time that would never work because you can't get rid of the heat. How do they solve that problem?
they produce less heat.
Okay.
Lower voltages.
Yeah, low voltage, and you change your you reduce the capacitance, you change the isolations. What they do now with multiple dies, so you just spread them out. Yeah. But yeah, when you start to pile things like that, especially that because it's a high power thing, you start to have heat problems. And they are much more tolerant to heat too now, which is. But you don't want to design that. And that's why I was getting to with the Verilog thing, is you don't want to have to draw all the things and make your own mask by hand, which people used to do, right? People were making the mask by hand. But yeah, now you don't want to do that. So that's why you want abstractions and things that are going to generate things for you. And that's what's happening with the Verilog for the ASIC programs that they do at eFabless and all of that.
In the 80s, they had these gate arrays that they put all the circuits on the silicon, and then you'd pay for a metal layer. That would wire everything together. So they had like amplifiers and transistors, and you would buy that, and then you'd pay for a layer that wired it together. It's still expensive. FPGA is like that, except imagine there's a bunch of RAM on the top, and you program how to wire
Yep.
it up, and you skip that whole step.
Yeah.
Right? It's just
So, and that's where the thing is. With FPGAs, the stuff is already on the board, and you are just putting the roots together with your software. The advantage of designing with Verilog and all of that is by the time you're ready and your design is ready and you want to sell 5 billion of them, you can take your Verilog and with really little change, have that on an ASIC. With all kind of issues that come with it. If it was working on an FPGA, it will be easy to put on an ASIC. If you want it to be much faster, then the fun begins of stuff that are not working the way you
Do you know
want.
anyone
No.
personally who has?
I know people that know people.
Yeah.
So on this board, If you didn't want to use the open source tools,
You can use the
you use like the Lattice tools?
yeah.
Okay.
Oh yeah. You just have to have the right LPF and all of that. You just have to describe the things properly, but yeah, they will work.
Okay.
And I think the open source tools can also use Diamond, right?
But will the Lattice tools understand
So you
this,
can-
this port?
Probably. But the thing is, the open source tools are also able to use for the place and route. They can also use closed source programs. So you can tell it to not use the open source stuff and to call Diamond for you.
Oh, I see.
So if you have some more advanced designs, you can just use a commercial
Yeah, 'cause
tool.
sometimes some of the libraries you get, you can't see them. They're just
Yeah. Well, and this, yeah, that's yet another level. In which case, you probably want to use
right.
the full commercial suite. Yeah, okay. So that's where we are. We are talking about generating on your FPGA a super complex thing that has Ethernet, that has all kind of crazy stuff. And for this example, what we are going to do, you can read that if you want, but I'm going to skip over that. And we are going to make a logic analyzer that has Ethernet. So you're going to copy and paste the Python code that's here. That's LiteX and MyGen code that describe how to use the LiteX cores so you have Ethernet and you have the logic analyzer itself. But it also has the same thing we did in Verilog. You will see there is a counter in there. So it's not in Verilog, but it's using the same kind of high-level description where you have wires and you connect them together and registers and put that together. And then MyGen is going to take that and transform it in high-level language that UCs can understand, and then it gets down the road. Okay? So it's one level above what we did with the Verilog. And if you want, you can import Verilog files and just take them inside your design as Verilog files directly.
I don't understand how this is useful, but you're not done yet. So.
Well, you don't have to. Yeah. Yeah.
That you can hack.
Yes.
I wouldn't write it from scratch. I would find sample code that did that.
Well, that's what it is.
Yes, I
That's
know.
what it is. And instead of doing it in Verilog, you do it in Python, which has a lot of advantages in how you're going to.
You are going to do it, right? Otherwise, we're going to kick you out.
Yeah, and you don't have to do UDP, you don't have to do Ethernet, you don't have to make your board respond to ping, you don't have to manage the triggers. All of that is done.
This all really started because Peter wanted to do this and he needed help. So we're here to help. So get help.
So that's the idea. It's you get it already done, and little by little you can take the parts and replace them by more advanced stuff.
Okay.
If you wanted to do that with just Verilog, you will need the Ethernet, UDP parts, you will need all of that. You will need to configure them and put them together in the right way. And so it's doable, absolutely, but it takes more time. And you could do it with NAND gates too, if you want, but it would take even more time. So the way it works, we import the various LiteX stuff. We declare the clock we are using. And that's used because the Ethernet needs its own clock and all of that. So you need specific clocks in them. Okay, we are telling it that we want the Ethernet. The IP address will be given later. Telling it which kind of board we have, which means that you can take that code and adapt it to another board by just changing a line. We say we want a minimal system on chip, so we are not going to have a CPU, a RISC-V CPU, we are not going to have HDMI, we are not going to have SDRAM and all of that. There is the example 5, we're probably not going to do it today, but the lesson 5 will get you with a RISC-V CPU and SDRAM support, and you can compile your own RISC-V stuff for it. It's just that it doesn't work on Windows, so yeah, we decided to not do that yet.
Someone on Windows, make it work on Windows.
Yeah.
Right?
What's up? Not me. I tried.
The last part, the last lesson, where you have a system on chip with a RISC-V, it's not working on Windows. It's mostly about adapting make files and shell scripts, so they execute the right thing. So it's not super complicated, but okay. So yeah, we tell it we want the Ethernet system with the MAC address we give, the kind of data width we want, the delays we want. That's the part where creating a signal, which is a kind of register we had in Verilog, making a counter. So every time I have a synchronization with the clock, so positive edge, I'm going to increment the counter by 1. So that's the advantage now compared to Verilog, is that you use the Python syntax to do things. So you can create even more complex abstractions above Verilog. So things that will take you all the time 20 lines of Verilog that you will have to copy and paste and repeat and all of that, you can just pack them in a module and reuse that. And make a really nice and one-line abstraction for it. So it's just one level above. Okay, then we call the scope analyzer, which is a module I already made for the logic analyzer. Say how big it is. Same thing, you probably can increase that. You will be limited by what the FPGA can do. And it will just fail the synthesis if you do that. You tell it which clock it uses, what's the sample rate, what CSV file is going to generate for its parameters. It's not a CSV output, it's the parameters of the scope. Because it's using a full-blown server that LiteX made, where it needs to know how the logic analyzer has connected its pins and what it can do and what does it see and all of that. And then you add the analyzer, and that's all.
And so where do you view the output?
That's after. So copy and paste that. That will prepare your board. And this is just, boilerplate code that's just going to get parameters from your command line, give that to the modules above to set the IP and all of that. So you don't need to change the IP here. You can change it when you build. You can add the parameter -- IP address and give the IP address I gave you on the paper. And don't mess up that because you cannot talk to it if you don't put your IP address.
You mean the Ethernet
Yes.
part of it, you're not going to mess up the chip.
Yeah, it's just not going to work. You will not be able to talk to it.
So when you build it, it's
By default, it will use that IP address. So you choose. You either change that. Yeah, you can change the code, or you give, when you run the build command, you do -- IP address and give the IP address. You choose. But change it one way or the other.
Or what's the other way?
You change the code, or you add this parameter to the build command. That's all.
But what about MAC address? Isn't that a problem if everything has the same?
Oh, yeah. I didn't think about that.
change the number, any number.
Yes, so you don't change the last number because there is some bits at the end of the MAC address that have a special meaning on a lot of networks. So you take this 72 and you use the last number in hexadecimal that you have on your IP address.
This poor switch is going to have a very broken
No. So what you do, you take the number you have on your board and you change it in the beginning here. The IP address you have, the last number, you put it at the beginning of that.
The switch is now a hub.
And that should work.
Is it already? Well, that's for years. We're wired, so we don't have that problem.
Well, yes, you have, because the switch will think that it's everybody has the same board.
If you're
Oh,
just
we're not hooked up to the switch, though. We're
straight
just
laptop to board,
laptop to board.
You're
with a local,
Oh, no, the people should connect to switch, not to the laptop.
why not?
This is a pass-through.
Unless,
Hold on, wait,
if
wait,
you
why
know,
not? Why not?
The
Because-
wires aren't crossed.
well, the problem, if you know how to configure your own network on your computer and fix an IP,
Got it.
that's fine for you.
Did that already.
The way, for everybody,
No, for us too.
yeah, okay. But for everybody, you use the cables that are on the table and you use them and
Alright.
you change these two values.
I was giving out cables to people.
Yeah,
I'll
no,
screw
th-
everything up while you're
It's
away.
if you connect to your own computer, that's fine. You use the IP you want. You set up the network the way you want. What we did here is that you just have to change these two values and you don't have anything else to do.
And the Mac, obviously.
But if you connect to these cables here, change the MAC address, or you will be unhappy.
And you specify the IP address when you do the build, correct?
Yes.
Yeah.
You change it in the code, or you specify when you do build.
So this is a logic analyzer strictly for Ether. But it imports the logic
It's
analyzer.
communicating over Ethernet. It's sending you the data over Ethernet. So initially, the logic analyzer was created to analyze the system on chip, to look at your CPU and look at the registers and look at all of that. That's why they created that.
How big is the CPU in this?
The size you want. There is no.
what
I don't remember. It tells you when you call the command. It's like a really. Yeah. I can tell
Because
you
this was an
that.
HDMI port on it, and you could put like a little screen on here and then have
Yes. So that's with the listen. Yeah, listen 5 has that where you activate the HDMI and all of that. And we are not going to do it today, but you have all the instructions on how to use it. And
We got about the same. Well, so when I ran it before.
yeah, it's a 32-bit CPU. No, it does not have the CPU at all. On this example, it does not have a CPU at all. It's a system on chip with no CPUs.
Well, so they're running. Does anyone else have it going? They all did it before.
Yeah, it works.
Well, we had an issue here.
If it's a communication issue, you connect to that first. I don't debug.
No, it was a JTAG error.
yes.
And so I bumped this up to 16 million, like it was, but it made it
Load is given a
slow, so it's taking forever to go up.
Oh, it takes a long while.
I mean, I already had it going because I manually.
Oh, this is really slow. No, that's a problem with your board.
No, we don't have a problem. The problem is the code.
The problem is the code.
I
The
used it.
Python code, but I think it's a Python code compatibility with the USB driver. Windows it can't run it at super low speed. But on Linux, I think it should work fine.
The mug was here and the pot was up here and I hit the mug.
So when I run ECP5, like before I ran.
Oh, yeah, those.
Yeah, okay.
No
If you run without the frequency, it goes really fast, it works fine.
Probably did.
If the Python script runs at a specific low frequency.
Okay.
And both
Yeah,
are
I'm not
both-
using it. Yeah, that's why I did not see that. Okay.
Yeah, the Python file calls it with a really low frequency.
Okay.
I'm sure that's out of your hands.
Yeah.
Well, we can change it. We have to change it so it works out of the box.
But I think it might work on Linux. This is my theory.
Yeah, I did not try
Oh, you didn't try it.
because I was using the other programmer for it, so I don't.
Well, I guess we'll find out. Has
Yeah.
anybody else gotten it going yet? Or are we the first?
Yeah.
Well, try it because it.
Yeah, you try it. I try it.
Okay, so it's here.
I can't do one.
Okay.
The end of it, yeah, I remember I had issues with VMs and I had some switch that refused to root stuff with the. I don't remember what it was exactly. Yeah, I think that's what it is. They are really specific MAC address that you can.
It says invalid response from probe. Line, I don't know, line 125.
But there's something about some of the bits that are used for
I
multiple.
can't seem to get it to load.
Okay, so you may have.
I changed the MAC address slightly. I modified some middle number. Put your address.